A ratio is a comparison of two numbers using division. Comparison of two numbers using division, and it can be expressed um, x to y, x to y, or x over y. These are all three ways they are the same way to state a ratio. So for right now, we're going to look at if the following ratios are equivalent. We're going to do this just by reducing them. So we take 2/3. If we reduce, that's already fully reduced as like a fraction if you think about it. If we take 16 over 24 and we reduce that with a common factor of both, we can divide both the top and the bottom by 8. So if we take 16 divided by 8, that's 2. 24 divided by 8, that's 3. 2 to 3 and 2 to 3. Yes, these are equivalent ratios. Now let's look here. Let's start with this one. We have 2/5. And if we wanted to simplify 6 to 10, let's say we divided both by 2. Keep in mind you have to divide both by the same thing. That's 3 to 5. 2 to 5, 3 to 5. Nope, sorry, these are not equivalent ratios. When dealing with proportions, and a portion is an equation that states two ratios are equal. And there's special names for certain things in equations. So if we look at this proportion, and we see that 0.2 to 1.5 equals 1.2 to 9.0. We have here on the insides here, these are called the means, M-E-A-N-S, of the proportion. And these here on the outsides are called the extremes of a proportion, which come into use when we use the means extremes property, which essentially means that in a proportion, the product of the extremes is equal to the product of the means. Product of means equals the product of the extremes. So essentially, if A over B equals C over D, and B and D do not equal 0, then A times D equals B times C. These are our means and our extremes. It's kind of like saying the cross product is equal. The cross product is equal. So we are going to use cross products to determine if these following proportions are, or these following ratios are proportions. So if we look at 2 to 3.5 and 8 to 14, we're going to look at the cross products. So is 2 times 14 equal to 8 times 3.5? 2 times 14, we have 28, equals 8 times 3.5 is 28. Are those equal in a proportion? Yes, they are. Let's look here at 0.3 to 1.5 and 0.5 to 2.0. So we set up our cross product, our means and extremes. So 0.3 times 2, 2.0, equals 1.5 times 0.5. And so we see that we get 0.6 and 0.75. Are those equal? No, they are not. This is not a proportion. we can use the means extremes property of proportions to solve equations using proportions. Let's look at this direction. Solve each proportion round to the nearest hundredth. So that means we might encounter some decimals, and that's going to be okay. So if we're using the means extremes property, that means that we're going to solve using the cross product. So r to 8 equals 20 to 40, or r over 8 equals 25, over 40. That means we're going to multiply 40 times r equals 8 times 25. So 40r equals 8 times 25 gives us 200. We divide both sides by 40, and r equals then 200 divided by 40, which is 5. We look over here, x plus 4 over 5 equals 3 over 8. We still use our means extremes or our cross product to see that 8 times the group x plus 4 equals 5 times 3. So 8 times this group, we're going to have to do a little bit of distribution. So 8x plus 32 equals 15. So I'll subtract 32 from both sides. So 8x then equals negative 17. Divide both sides by 8. And so x equals negative 17 divided by 8, which rounded to the nearest hundredth, we get negative 2.13. Hundredth, remember, is 2 decimal places. Alright, let's look at our practice problems. We have page 329, numbers 9 through 23. So number 9 asks us to determine if each pair is are equivalent ratios. State yes or no. So number 9, we have 9/11ths and 81/99ths. You can use the means extreme property to see that 9 times 99 equals 81 times 11, because we see and we know that 9 times 99 is 891, and 81 times 11 is 891, and these are equal, so yes, this is a proportion. We skip a line and go on to number 10 and have fun.